Hello everyone, my name is Nabby Petit-Home, Global Product Marketing Manager for Johnson Controls, and I have the privilege of moderating today's discussion. I'm joined by several Johnson Controls colleagues and fire protection experts. Joining us for today's discussion are fellow and VP Industry Relations, Dr. Rodger Reiswig, Global Director of Codes and Standards for Fire Products, Chris Downing, Fellow Industry Relations, Alan Elder, Director of Industry Relations for Fire Suppression Products, Sean Cutting, and Global Product Manager for Portable Fire Extinguishers, Danielle Felch. So Johnson Controls offers an extensive range of products and solutions across building controls, thermal management, fire protection, and security, uniquely positioning us as a leader in creating smart, healthy, and sustainable buildings. Today's conversation will be centered on fire protection. Our goal is to arm you, the audience, with the information to better understand the rapidly and ever-evolving fire risks in data centers and have an open dialogue around what should be considered when creating a fire protection strategy. We do want to make this an interactive discussion, so for those of you who are joining us in person, feel free to raise your hand. For those of you joining us online, feel free to type your question in the chat and we will address those as they appear. So, data centers aren't new, but we know that the landscape is rapidly evolving. What are the challenges and how is it affecting what we can do as well as codes and standards? Chris, I'll throw that first question to you.
Thank you, Nabby. Technology is ahead of and certainly outpacing codes and standards. For example, if we take AI, we're all using it more. You've got direct-to-chip and cold plate cooling. That really moves things. We no longer have high airflow providing the cooling. So if you're slowing down the airflow, how's the smoke get dispersed? Where is that now traveling to? So I think on the codes and standards side of things, that's a big question. We'll start off looking at what's going to burn and how would we detect that. So maybe Rodger, would you mind?
Yeah, that's a great segue for that, Chris. In data centers today, they are larger and more commonly used than ever, and for a variety of reasons. And when we look at what could burn, obviously it's going to be the power supplies, the batteries that might be secondary power, if there's some kind of maybe a battery storage assembly that's there, or off-site generator on the premises. So we're interested in all of those. But as we look at data centers and how they've been used over the years, it's kind of changed. It's been more for, I want to just store files, and then it's migrated to more of offloading as our connectivity pathways have really kind of blossomed. I now don't have to have the programs resident on the computer. I can have them in the data center. And then now with AI, as you talked about, really promulgating itself in all aspects of our world, the need for data centers is really grown.
Would you say we need a Titanic-type fire to wake up, or do you think we're getting there with codes and standards?
Well, back to your question. That's a good question. I think a lot of it we're there, and inherently, if a data center, if we detect a fire and we start to shut down computers or the storage devices, they inherently already are duplicated or redundant in other areas. So a Titanic catastrophe, I think we've had a few of them. When I look at some of the data centers, even in the US here, that have had incidents occur. To the public, it's been maybe a minor change or maybe a slowdown of how they're interacting with systems. But I think we're kind of there, at least when it comes to, do we need a Titanic event, if you will, to really move the needle? I'm not sure if we're there or needing that at this point.
Yeah, I think just to add to the comments that have been made already, this landscape has changed and evolved dramatically over the last few decades, and it's accelerating at an even faster pace. I think when we look at the legacy computer room that eventually evolved into what is today's data center world, we were basically protecting a box because everything was shut down. The computers were shut down, the air handling was shut down, Now it's very different. It's very difficult now to shut down the data processing. Very difficult, if not impossible in some instances, to shut down the air handling units that serve that facility. So a very different landscape. The methods of detection, the methods of suppression, first-hand and second-hand firefighting are very different to what we experienced decades ago. The replaceability of materials within the data center has also changed. Quite often in the past, everything that was necessary for the running of that business was actually within the computer room itself. Now it's all backed up on the cloud and in data centers, and the dispersal of all that data are in many cases around the world, not just in one particular geography.
Can I interject? We're only a few people in the room and we can't see thumbs up or thumbs down the way we're streaming. Here, if I said to you here, we're going to turn the power off in a data center, do you think, yeah, that's good, we still do it? Or you look at me and go, dark ages, just don't tell the AHJ, but yeah, okay, right, so power does stay on. And I think that's where everything needs to catch up, because the codes are still very much predicated on power is killed. If you're going to deploy a water system, you understandably want to take the power off. If the fire and rescue service or the fire department are going to attend, they're going to kill the power, and that abrupt power loss can be as catastrophic as an uncontrolled fire. So
yeah, and I think when we talk to data center operators and designers of data centers, they just say one of the things that we can't do is kill the air handling. Killing the air handling is almost as bad as a fire. And so as we design detection systems, as we design fire extinguishing or suppression systems, we have to be mindful that you've got that potential for a constant airflow. And we design into our systems for those scenarios.
So, Alan, you just touched on detection. I'd actually like to throw this question to you, Dr. Reiswig. What factors, how can engineers balance the need for high sensitivity in detection systems with the risk of false alarms in data centers?
No, that's a great question. And we struggle with that in all aspects of detection. We want to be able to detect a fire or a possibility of a fire as quick as we can, but we don't want to have a nuisance alarm or an unwanted alarm. And one of the things that we have found is, even if you want to use a air aspiration type of detection system, is maintenance is key. As long as the systems are maintained properly, the filters are cleaned, they undergo the proper maintenance and calibrations that are needed when called upon, that's probably the biggest way to, I don't want to say eliminate, but almost eliminate your nuisance or unwanted alarms. Because these systems are designed to detect very small microscopic particles in the air. And they can also, just as an offshoot to that, they can also be used as multiple stages, where I can have a very, very sensitive device alert me, as maybe a maintenance person, that something might be going on in this area, go out and investigate it because we don't want to shut anything down. And then as if it is a fire and it starts to grow, it would get to another level, and then that could alert and maybe start to activate pre-action systems. Maybe we do start to shut things down or do other things. But a lot of customers do seem to like the idea of giving me a pre-alert or a quicker alert that something's going on. Let me send somebody out to investigate it, see what's happening, maybe even take care of the situation. And if it does happen to grow farther, bigger, more heat, then it would just automatically do what it needs to do. But the equipment today, particularly with the new UL standards, has done a really good job at, I don't want to say eliminating false alarms, nuisance alarms, but as long as the equipment's maintained, I think we're kind of there in the industry.
Sure. Chris, you'd like to add?
if I may, I want to engage with the people in the room. So having heard what Rodger said there, I don't know whether we're going to see more edge data centers, unmanned data centers, where it's great to know there's a fire, nobody's going to get there quickly. Remote hands might be able to, but the first person that gets there is going to be the fire department. They may have to force entry, but invariably you've got a data center that's impenetrable. They're going to go in with hoses, abruptly kill the power before they get a shock, squirt everything. How do you feel in the room about that? Does that sound real? Linda?
A question on the fact that
Yeah, and it's a great question, a very valid question, and I think that, the answer to this is that every particular instance, every particular facility has its own nuances. That is it possible to shut down the power? Is it not possible? Would that lead your thinking towards a clean agent system? What are the stages at which you would deploy active fire protection? So we start with the detection. It may well be that at a very early stage you could deal with that incident with a portable fire extinguisher. Then you may go into gaseous suppression. And if none of that has mitigated, or none of that is actually available, then the sprinklers will come in. Maybe that is the point that power has to be shut down, because you're now into a situation where you are trying to save the building. Your business continuity as far as the assets within the room are actually now irrelevant. We've got to the point now where those are probably irrecoverable, and it is now about saving the facility and not the business interruption piece.
And before you get too much further with that, though, could maybe we back up for the audience that might not know the difference between a true sprinkler system, a water mist system, or a gaseous system? Can we kind of maybe understand what the three are? So if you want to start maybe with the gaseous stuff, and then Sean, if you could jump in.
Yeah, sure. So for those not familiar with a gaseous system is a very clean way of extinguishing a fire, whether it's a halocarbon, which is absorbing heat, or an inert gas, which is reducing oxygen levels. The intent of those systems is to discharge into that fire scenario, usually at a very early stage before that fire has become significant, and it is extinguished cleanly and safely. One of the things that we always try to do when we're talking about a fire protection strategy in any premises, whether it's a data centre or any other, is what is the key objective there? And with a gaseous extinguishing system, and I do focus on the word extinguishing, the premise and the basis of the design of that system is to extinguish a fire. Other protection measures, and I will hand over to Sean, is to look at what we're doing to stop the spread of that fire. So we're talking maybe about suppression, about control, and maybe extinguishing is a bonus that may come with the action of a water-based system. But the intent of a gaseous system is to extinguish a fire. That's what it's designed for. You look at the codes, they don't hide behind suppression. They say these are extinguishing systems. And so with that introduction on the gases,
may I step in? Because there's one thing I think really important there is a gaseous system will get everywhere. There's no shielding, so unlike a cabinet and IT rack that a sprinkler system may as well see as an umbrella, it gets everywhere. They're human safe, so you don't need to incapacitate the system when people go in. But we're talking of fire. If we've got an escalating event, you can deploy early and prevent there ever being a fire. And so I think it's really important. We understand it's an extinguishing, but you have like an Edison light bulb effect going on, so you can keep power on, do a graceful shutdown, do what you need to, but it doesn't need the fire to start to work. It can stop that fire happening. Sorry, Sean, over to you.
It's all right. Thank you. Yeah, so probably everybody's familiar with sprinkler systems. Sprinkler systems are there for water-based suppression or control, or maybe just life safety in the building. So it all depends on your occupancy and the fire load in the building, what type of water-based system you want. Water mist systems are the same but higher pressure. So there's intermediate water mist systems and high pressure water mist systems. In most instances for solid fuels, they'll be using less water than sprinkler systems, but not in all cases. You have to think about the smaller droplet size if you have high ventilation rates, things like that to consider. So it's not always a direct alternative to sprinkler systems, but it can be.
And I'd actually like to, so Danielle, right, Chris mentioned, hey, we think about this as an evolving event. I don't want to miss the opportunity to talk about how portable fire extinguishers, right, can oftentimes be our first line of defense, right? So, what factors should be considered when selecting a fire extinguisher for protecting a data center?
Well, I think what everybody said, what's really important is that it doesn't conduct electricity, and it can't have a residue once you discharge that extinguisher. So, our Clean Guard or our Clean Agent type extinguishers, that's exactly what they're there for. And like you said, Nabby, if that's going to be your first line of defense, if that's part of your firefighting strategy, and you want to activate that fire extinguisher, outside of hard pipe systems, you are required to have a fire extinguisher in that building for occupancy. So for extinguishers, you're going to want to take in consideration the minimum room volume that is needed for that, and then obviously it needs to be a non-conducting Clean Agent type extinguisher. So that's where the Clean Guard comes into play.
Awesome, thank you. So a little bit of a question that I'll toss to anyone who wants to answer it first. But how might fire protection strategies differ between regions? So let's say you have a data center in one region, but that is owned, right, by a company that might be in a different geographic region.
That's a good one, and we quite often see that. If you look at how the world is now, particularly with the hyperscales, they will have their cookie cutter predicated on US code, which will start with sprinklers to safeguard life and protect the structure from spread to adjoining. Go to the rest of the world, that may not be required, and so it may be that the stakeholder group has to be fully engaged in that decision-making process. Do I have to have sprinklers to be able to operate the building and turn the lights on? Do I then want a gaseous system to safeguard that? Do I have immersion cooling? And actually, that may necessitate a water mist system instead of a gaseous system. Am I going to have people present to be able to use portables? If it's a black box and there's no one there, you need portables for when people are there, but you can't rely on that in your strategy. So I think you need a good stakeholder group to sit down and robustly say, what is available? Who's going to do what when? What's the fire and rescue response time like? Do I trust them to go in? Would I rather have a system where I actually stop them going in and I can hold them off because I've never had the fire? So I think it's a tough one. I can't answer that. You've got to understand with the stakeholder group what their expected and allowable losses are, what their control measures are, what their operating procedures are. I don't know how anybody else feels about that.
And I think one of the one of the key aspects of this is the codes as well. In a particular region, there may be a code requirement for a particular level of protection that might be different in another region. The US is very code driven. Other parts of the world it may be less so. But where those codes are either applied or not applied, then will be a difference in how you actually apply those protection measures based on the standards that apply for that particular jurisdiction and what the approval requirements are that are implicit perhaps within some of the standards. Obviously North America and parts of the other parts of the world are quite dependent on NFPA. In Europe it's European standards, and then rest of the world you've got regional standards and in some cases actually applying European or NFPA standards.
Along with that, sometimes we look at what the end user, the owner's life safety goals are. There are some end users that we deal with who will say, if there's a little bit of smoke, heat, something's going on, shut everything down. I have redundant facilities around other places. Save my equipment because it's very costly for me to have to replace that. Other facilities that we go to, they're like, I don't have a lot of redundancies. There's not a lot of other places for me to go. Let the equipment work until it dies. And if you guys can stop it with gas or a portable extinguisher, great. It just depends on what the mission of the data, what the facility that we're using. And it's interesting when you look over the years, as you talk about NFPA, we've had NFPA 75, which is for IT-based equipment, and we have NFPA 76, which is for telecommunications. Those worlds have melded together today. We don't have a true telecommunications system any longer, at least in the US. Everything now is voice over IP. So I'm now using those data computers to also do my voice communications. And back in, when we go backwards a little bit to see where we are today, at that time, we used to say for telephone equipment, it's going to work until it dies. It needs to be there because it's critical, and I need the people to be able to pick up the phone and use it. We don't do those anymore today. But the IT side, it was the opposite. They're like, data, I don't care. I have other places. Save my equipment. It's precious. It's very expensive. Just shut it down. So that's another component that comes into play is what is the end user? How are they using it? What goals do they have for their systems? And that plays a big part.
So I actually have a question that came in online. I might actually throw this to you, Rodger. Have you implemented AI or machine learning in detection systems to reduce downtime or improve predictive safety?
So that's a good question that I think that we and others are wrestling with when it comes to the life safety world. There was and so I'll go a long way around to get to your question. There was an AI summit that occurred about 3 weeks ago in California, hosted by SFPE and Berkeley University. Predominantly, they're looking at AI in predicting how fires might be spreading, mainly in the urban wildlife. We have forest fires and brush fires and propagating from house to house and taking down communities. When they were talking about how could we use it for modeling, maybe to help evacuate people, or maybe figure out if a fire is starting to occur, how might it grow inside a building. I don't know if we're really there yet. Because when you look at a typical building, I don't have smoke detectors everywhere, carbon monoxide detectors everywhere, heat detectors everywhere. And you need all of these different types of detection methods to be able to help you understand what's going on in the facility, to be able to then feed it into some type of an AI generator and say, okay, based on this amount of carbon monoxide, this amount of heat, this amount of smoke, and in these various areas, this is how the fire's progressing and moving on. All of that to say is, no, there really isn't an AI answer today that I don't think any of us have in the life safety realm. We have good practices. We have modeling software that we use where we can try to figure out how big of a fire might occur based on the equipment that's in there, how many kilowatts of heat are we seeing or smoke density we might see over time, and then with that figure out the type of smoke detection, the sensitivity levels we want to use, and other things. But as far as an AI modeler, I still think we're a little bit off on that.
Sorry, Alan, about my vote. AI. I'm told if I use it at work, check for hallucinations, don't trust it fully. How do you feel about that in the detection world? Do you think the codes and standards, and particularly the consensus base here, even if we come out with the great device, will the world take it?
So that's exactly come up or that discussion has come up here recently. If I have an AI system and I'm feeding it all this data, and I'm telling it to maybe not shut down an air handler, but maybe reduce its speed, or maybe turn off a zone or an area. But what if I fed it wrong data, or the data they saw it didn't think was correct? And if we get out of data centers for a second and we talk about, well, I know there's a large population of people on the 5th floor on the east wing, so I want to tell them how to evacuate. It's like, do you really want to tell people how to evacuate automatically and possibly put them in harm's way with AI? And so I don't want to say AI is not coming into the life safety world. I think it's going to be, like everything else, it's going to be very cautious. When we look at life safety systems, they don't adopt cutting edge, bleeding edge technology. It's stuff that has to be out, proven for a while, and then maybe they'll bring it in. Which is good and bad for the life safety world, but that's kind of where we are today.
Okay, I actually have another question that has come in online. Let's see. These days, data centers are coming with energy storage systems in them. Does Johnson Controls have a suppression system that is specifically listed for energy storage systems?
I think you could ask that question to the whole industry, and I think you would get the same answer. I think there's different levels of protection that can be applied to energy storage systems. The golden bullet has often been described as a system that will stop thermal runaway, and we've seen many presentations here. There's much discussion around the world of what is possible in respect to stopping thermal runaway, and the answer is, once that's started, nothing is going to stop thermal runaway. So it goes really back to some very basics, that if you start to detect very early, detect something going wrong within a battery, and you can perhaps via the battery management system prevent that spreading into a thermal runaway event, then that's your first line of defence. There is a lot of work going on in different parts of the world about what happens once you've actually got to that thermal runaway stage. What would your protection objective then become? And work that's going on in Europe at the moment to write standards in this space are probably going to focus more on thermal propagation and actually stopping that spread from a cell or a number of cells that are in thermal runaway. How do you actually prevent that then spreading and propagating to further cells, and eventually you could end up with a complete loss. So in terms of fire suppression technologies, yes, we have fire suppression technologies that can be effective against preventing thermal propagation. Do we have fire protection products that can stop thermal runaway? No, we don't, and I don't think anybody else does at this particular moment in time. So it's all about managing the risk and doing what you can do, and not trying to do what you can't do at the moment. I think that's the most honest and open answer that we can give on that at this stage.
Can I add to that? So we're talking a lot about us as life safety people and how we can suppress or control a fire from a battery system, but the battery manufacturers also play a key part, and they're recognizing what's going on. And some of the things that's being discussed as I've attended some of their symposiums is the casing material around the cells, that they're able to stop it so it doesn't allow propagation from one cell to another cell and cause runaway. They're also looking at embedding sensors in their batteries, and they're able to predict up to 2 weeks in time of when a problem could start. So if they're able to give me that signal, and then I can tell them, hey, cell number 35 potentially has a failure, they can go in preemptively, open it up, pull that cell out, replace it, and move on. So there's a lot of things that are going on with this. It's not just the best way to maybe suppress the fire, but also if we can control it or even understand how it could start to begin with, is on their side.
And I think to add to that, when we talk about extinguishing in a fire within a battery or a number of cells, or stopping that thermal propagation, what we've also got to be mindful of is that as the batteries start to degrade and that process from the thermal runaway, you've got a lot of explosive gases being given off, and so that strategy may be that actually to extinguish the fire just shifts the risk from a fire risk to an explosion risk, and so you then look at whether you've got explosion prevention, you've got venting to take away those potential toxic and explosive gases. So there's not a single answer to this. I think it's one where you have to look at the overall risk that's involved, and then design your mitigation systems against that risk. Of course, when we talk about battery energy storage systems, we think of a containerized box. Not all UPS, not all applications of batteries are in a nice, neat box with a roof and a solid floor. And so again, that would affect how you look at the fire prevention and the fire protection strategy.
If I can join in on this, I think the good thing about energy storage is generally that's expensive. It's going to be well installed, built and maintained, and so we shouldn't confuse that with abused batteries that could be in a car that gets crashed or an aftermarket e-bike add-on. So we hopefully will be able to better detect. I'm with you on a controlled burn, but certainly whenever there is a fire, it's sensational, it's great, it's newsworthy, and nobody ever sold a newspaper saying war didn't break out in England today. So I think there is that, but it's interesting times, and that's where we've got a problem trying to keep up with that, and then also get codes and standards to keep up with that as well.
So that's actually a great segue. I think we've talked about looking at the overall risks, right? Making sure that we understand the objectives. How can engineers and technicians better advocate for enhanced fire safety measures in data centers to non-technical stakeholders?
Okay, I'm quite happy to grab the mics on this end. That's an interesting one. I've always enjoyed this. I think it's critical you get a good stakeholder group in the room. If you've just got the HA, if you've just got the if you've just got the HR person, all they're going to want, did everybody get out? If you've got the business continuity person who say, I don't care about the people, did everything stay on? If you've got the salesperson, they're going to say, did my customer have an outage? I'm quite fickle. I turn on my telly, try to look at, can we use names? If I look at Netflix and it's slow, I get the buffer wheel, I jump to Apple. That's the way the world is. So I think it's important to get everybody in the room and they understand and they agree what is an expected and an acceptable loss. Because you may say, what do you mean you're turning the power off? You may say, I don't care about the power. And so I think that the first thing for them to do is make sure they got everybody in the room and to timeline it, to walk it through conceptually. The problem with a data center, if you've got a shop and you want to do a stock take, we do it at the weekend when we're closed. Data centers are always on, and that's a challenge of believing it will work, checking the processes still work, checking everybody knows about it. So it is a tough one. I don't think you can define that around the world. That goes back to if there's a plentiful supply of water and the code says you've got to have sprinklers, you may say, well, sprinklers is enough. Do I want to put a gas system in as well? Go somewhere where water's scarce and you're not going to get anybody responding for 40 minutes. You probably say, I want a gas system, and remotely I'm going to gracefully shut things down or turn off offending item. Does that answer your question? Do you think?
It does.
Well, I don't know how others feel.
Does anyone else want to add?
Just to add on to that, I think also it's educational awareness. Data centers are unique in the industry. They're different than an educational facility, assembly occupancy. And to help to educate how we could have different ways of detecting smoke, heat, other trace elements that might be out there, carbon monoxide, different ways of suppressing a fire, and multiple ways of suppressing a fire, whether it's gas, water mist, sprinkler, and then also understanding the customer's needs and make them understand what the needs are. You know, a lot of times it's like you flip it back to them. It's like, let's do kind of a risk analysis or hazard analysis, mitigate it. What is mission critical for you? You know, and some customers are like, I don't care what happens, shut everything down. And other customers are like, I don't care what happens, don't let anything turn off. And so we need to know all of that, you know, up front. And like I say, a lot of it is just educational awareness and getting a good fire protection engineer, somebody on board that can help become the master Lego builder. Because a lot of it is we have a lot of parts and pieces that can do a lot of different things, and it's assembling them all, whether it's extinguishers, different suppression systems, detection systems, what have you. And it's understanding what the risk is, how you're going to mitigate that risk, and then using the parts and pieces to make the best solution.
I was going to shamelessly plug us then, but there are others out there that are like JCI. But that's the benefit of a company that has everything in the arsenal to help you identify what would be right for you, which may be different to you, rather than, well, I've only got one product, so guess what? It's right for you, and I'll shoehorn it in for you and you as well. But there are others out there. For the fire protection engineers, I think they've got to genuinely consider that timeline. What am I expecting? How's that going to happen? And what's plan B look like? Which is beyond codes and standards. Standards will say how you then deliver it to make that happen. But you've got to think about the expectation.
Codes and standards are the minimum. Good point.
If I could just add to that, you were on something. Because NFPA 232, which is the standard for protection of records, has that the guideline of how much risk does the owner want to take. So they label, they put different records in different criterias, and then they have design criteria to meet those owner risks of what they want to take. How far do they want to take the risk of a fire in this particular record storage? So I think that's the key, is these data centers, each owner has a different risk level, whether, shutting down the electricity or letting it go, or, and that's what the code world needs to, really focus on. And I think we need to expedite a data center NFPA code on, how do you protect these? Because right now they're being protected by what the owner is saying they really want and how they want it protected. Because I was in Dublin, Ireland last year for the International Fire Sprinkler Association, and they have a lot of data centers, and from Meta to Microsoft to you name it, and each one of them said they had the owner pushed the criteria, because as we know, Europeans don't have the code level that we do. So it's very interesting. I think that's kind of the direction we should really focus on.
Yeah, and I think what you've just done there is summed up what we've really discussed, in the sense that it will be up to the owner operator, the stakeholders, to prioritise what is important for them. And if they say this is 100% can never ever fail, well, that's never going to be possible. But when you get into the 99.9, however many decimal places after the 0.9 there, you will start to ramp up not only the provision of the fire protection, but the cost that goes with that. You could put everything that we've discussed here, they could all go in, but there's a limit to what is going to be effective, and what people are prepared to pay to go to that level of protection.
If I may, can I build on what Linda said there? I agree with you. In the olden days, we had RAID, random arrangement of independent disks. So you'd spread the data over 5 disks, and if one disk fell over, well, the other 4 could pick up the strain and you wouldn't lose anything. And I think the hyperscales you speak about have that random arrangement of independent data centers, not disks. So they're spread out by diversity. They've got resilience in that way. And one of the things that worries me, you'll have an enterprise that will think, these guys know their stuff, I'll use their cookie cutter and I'll have RAID all in one rack or all in one data center, and one event there could be existential to them. And they go, well, hold on. And I think there's that disconnect, and that worries me.
Okay, I am going to take a question from LinkedIn. We'll do 2 questions. One person asked, are we aware of mechanical HVAC code developments being altered to develop a more feasible strategy for operation during a potential fire event, or additional verbiage to avoid shutdown requirements that could actually be creating a more fire-prone environment caused by shutting down HVAC, preventing data center equipment from overheating?
So we're a fire panel here today, not the HVAC. We have that in our business. I would say you need to understand what the HVAC is delivering. If you're going to remain on and things will get very hot very quickly, you need to have air supply. If you have free air cooling, so you are honestly sucking outside air, take Scandinavia, it's perfectly there, might need a bit of filtration, and then spitting exhaust waste heat out. You're not getting the accumulation, so you've got to think, what will burn? Where's that smoke travelling? But it won't build up. If you are then going to have a gaseous system to protect that environment because it's always on, your cause and effect has to say, I stop free cooling, I go into recirculating cooling, and I put the gas in, and the recirculating, if it runs, you've then got to ask yourself, does that help or hinder the fire protection? So actually, that might be a good one for you, Alan, if I throw that to you.
Yeah, and this has been a subject of a research project that was done between the FSSA and the FIA in the UK to look at the impacts of air handling within this type of environment. You know, what happens to the gas when the air handling is shut down? What happens to the gas when the air handling continues to run? And this all assumes that this is fully recirculating the air within the space. And the very general high-level result of that research project was that, if anything, keeping the air handling systems running actually helps with the mixing of the gas and creating that homogeneous atmosphere within the space. Now, that may have some challenges for detection systems, of course, because you're moving the air. It may have challenges for some of the other technologies, such as water mist, which are relying on less buoyant, more buoyant particles. But in terms of how that air handling works with a gaseous system, the research has shown that it actually will, if anything, be a positive attribute to the way that the gaseous system would actually work.
Okay, so this is a question for you, actually, Danielle. So high-density data centers are designed to maximize computing power in compact spaces, right? So how can extinguisher placement be optimized in high-density data centers to ensure accessibility without disrupting airflow?
Yeah, so per NFPA 10, which governs the selection, inspection, maintenance of fire extinguishers, they do define the maximum travel distance to that extinguisher, and you also have to take in consideration the fire load. So if it's a high density area where you have a higher fire load, you're going to need more extinguishers in that space, spaced closely together.
Awesome, thank you. And then I will go to another question here online. Can we share any insight on successful containment strategies during fire events in Tier 3 or Tier 4 data centers?
Well, no, do you want? Okay. So the tier system is a funny one. That's basically saying what's your uptime, and that's looking for mean time between failures when things go wrong. How often do you plan to have a fire? And that's the awkward one. I'm very much if it's mission critical to you, if it's a game over situation, if there's a fire, I would certainly say aspirating detection or very early warning fire detection. Human intervention, go in with a portables, you build up those layers, you then have a gaseous system, and maybe it's last resort, but code may say you're going to have sprinklers, so you have sprinklers. It's not answering it. You're using the wrong rubric to measure there, because they're looking at, well, what happens when you have a power loss? What happens if you have this? We sit there quiescent doing nothing until you have a fire. It's a tough one for us to answer on that, I'm afraid. But I would say where you have a higher dependency, if somebody's spending a lot of coin getting a Tier 4 data center and not a Tier 2, they're probably going to say, I'm prepared to fork out on gas. So if something small happens here, it's like an incandescent light bulb. I've lost the capacitor. It didn't take out the rack, the room, the floor, the building.
Thank you, Chris. So we've touched lightly on thermal runaway already, but I will take this question online. What is the panel's opinion on lithium-ion battery backup battery units installed within server cabinets and potential viability of water additive fire encapsulation products to control lithium-ion fires?
Okay, so as far as encapsulating agents, because that was the last part of the question. There's been research done in many parts of the world on different additives that are included within suppressing agents. I think the jury's still out on what level of protection can actually be given by encapsulating agents. There are products that have been tested that show perhaps a greater protection against thermal propagation. I don't think we have a conclusion to which ones are more effective than others. There's an interesting research project just being concluded at the moment in the UK, where Newcastle University, in a project partly funded by the UK FIA, has tested a number of agents on battery packs and have measured the thermal propagation between the different modules within those battery packs. And so I think it's, at the moment, it's again one of those that lithium-ion batteries is still this mystery. We know what we can't do as far as thermal runaway is concerned. We know that we can control or prevent thermal propagation. The agents that are involved in doing so are still very much in the research phase, from encapsulating agents to vermiculite and etc. The different types of additives that could go into that. Sure.
Yeah. So Alan's absolutely right. There was actually a presentation here yesterday on encapsulating agents, and it comes down to the type of battery, the type of fire, and the resultant could be one encapsulating agent may work better than the other, but you may have stranded energy afterwards. So there's not just the suppression aspect of it, but what happens afterwards also.
If I may, I'd say as well, it's really important to not confuse something that's claimed to work on a portable because you've got a cell phone or a laptop on fire, and we're looking at that to a larger scale, which is what Alan said earlier on the SEN testing. Going back to your question, Nabi, about in-rack battery backup, if you read the FM data sheet, they're kind of like, no, you can't use a gas there. I would rather say, understand what you're trying to achieve and how, and that's where it needs to be a specifically engineered design. For example, if it's a fire that's not the battery, the gas system will stop it becoming a fire or getting to it. If you're trying to protect things, if you've got a huge volume, something the size of a football pitch, and you lose a rack of batteries, I don't know how much off gas will be produced and whether you would ever get into Alan's vapor cloud explosion. You'd hit enough of the flammability limit. And I think the FM data sheet that is, I can't think of the words we use now because I would use two colours. I think it's a shades of grey. It needs an engineer to say actually how much off gas would be produced if it's the battery. Am I trying to control that? Do I expect that to have a controlled burn, but I protect everything else? It's a tough one, and that's where the future will be very interesting.
Okay, so we have another question online. I'll ask the question as it's come in. So, with growing emphasis on eco-friendly and electronics-safe fire protection, do we see hybrid systems like the Victolic Vortex becoming a mainstream standard for mission-critical data centers in the next decade?
I have a view on those hybrid systems being one that most of the work is actually done by lowering the oxygen content within the space, and I would say that in terms of protecting a data center or any other facility with a system, I would go with gas. I would favour gas because you've got with the gas you've got that, and Chris touched on earlier, the penetrability of the gas. It is clean, it is safe. If you are looking to use a gas and a water based solution, then let's design a gas system and let's design a water based system. I'm not totally sold on the mixing of a water mist and a gaseous system. I think they are applications that are maybe suitable for that type of system. I would not be promoting that or suggesting that is a good solution for a data center. I would go with, if you're talking about the best of both worlds, after the portables of maybe not done their job that they were intended to. But if we've gone past that point where the portables have been tried, and then I would say use a gas and protect the building with sprinklers or water mist, depending on the type of space that we're involved with there.
I like different opinions, so Sean, you go and then I'll go, and the audience can take away the bits they like.
So one of the interesting things about hybrid systems too is the same system in a different environment could react differently. So depending on the volume of the space, your hybrid system could do its extinguishment through the water portion. In a different space, it could be through the gaseous portion. So I think Alan's absolutely correct. If you're going to use one of those systems, use one or the other and try not to mix them.
And if we understand what the hybrid is, it is a gas system with added water smashed to small size for cooling. In a data center, if we've caught this incipient stage that's not yet hot, do I want to bring water in there in any quantity? And am I trying to achieve cooling? Probably not. Do I want the added expense of bringing in the water if the gas would do? But I think if you've got something that will be hot quickly, it could be useful. So maybe if you've got a generator set and you've got an inert gas system, you say, well, with a selector valve arrangement, I'll entrain water in just that. I would not bring water into the white space of a data center. Any other opinion from people here? Because at the moment you're hearing those questions. Anything else?
Okay, so I'll ask, if we look at what the future might be, what lessons can fire and life safety professionals learn from major incidents or failures?
You're asking the wrong industry. The data center industry is so tightly bound in NDAs that when a disaster happens, news doesn't break. So I would love us to share more news, even if the Uptime Institute does a cracking job of trying to do that. But I think the culture there needs to change of saying, we will let you share our losses and our lessons learnt with anonymity. And I think that to me would be a great scoop for fire protection in this space.
But I also think that some of the incidents that have been reported, when and Chris is absolutely right, some of that information and the inquest into what's actually happened there can be very tightly controlled. But what we have seen is that all the technologies that we've discussed today, whether that is water-based, whether it is portables, whether it is gaseous with advanced detection, we find that many of those elements have been missing in those instances where something has gone very, very badly wrong. Some incidents we're aware of where, you just say, well, why was there not a gaseous system in there? Why was the building not sprinkled or protected with some other measure? And I think that's probably the one thing that it does become a little bit more public knowledge when you think of some of the reports from some of the big data center fires that have occurred. They just were not adequately protected,
Okay, I actually have a question that came in online. I think, Danielle, this might be for you. So this person says, I work in the industrial world. What do we know about using cleaner, eco-friendly suppression systems to avoid having the operation using SCBAs, which in turn saves the customer thousands a year? Do we have the same type of eco-friendly portable extinguishers coming to the market?
Yeah, I mean, our CleanGuard Plus extinguishers, they have great environmental properties, low ozone depletion, no global warming potential, and a very low atmospheric lifespan. And then when you have to, another thing to consider when you're looking at a clean agent option is the overall toxicity of that agent. And when you look at our CleanGuard extinguishers, in the industry, we have the lowest room volume requirement to protect those spaces. So when you look at data centers, they range anywhere from large scale to very small remote closet spaces that we can protect with that environmentally good extinguisher. Oh gosh.
All right, so we've got about 5 more minutes. So if we don't have any more questions in the room or online, I'll just check here. Nope. Okay. So what I'll ask of the panel is just to share what would you like the audience to take away from this conversation in terms of protecting data centers. Sean, I'll start with you if you don't mind.
So I think we talked a lot about different options, different solutions. One of the things that I think we could do better as an industry is move faster and think outside of the box. The IBC just this year is putting in classification for data centers. So there's a proposal to add in that occupancy classification in the IBC. It's not in there yet. I'm hoping that there's not too much resistance to it because, as we've been talking about, data centers have very specific needs. So I hope that goes through. One of the other things is, I think it's been mentioned a couple times, data centers are coming up with new technologies faster than the fire protection industry can keep up, right? Some of that is codes and standards, some of it is just resistance to change. I read an article recently that said data centers are thinking about moving and relocating next to nuclear power plants so that they can get their energy directly from the source rather than off the grid. Those are the types of big changes that data centers are thinking about, and the fire industry is not ready for that big of a change yet. So we need to open up our eyes and think out of the box more.
Yeah, so I think one thing that everybody kind of really touched here is it's really important to define your fire strategy and make sure that all of the stakeholders are there. Are you going to shut the power off? Are you going to leave the power on? Are you going to try to address that fire with a portable extinguisher? Or are you going to rely on that gaseous system? So I think it's really important, and everybody has said that's one of the biggest takeaways is you need to fully understand how you're going to fight that fire and what you're going to fight it with.
Yeah, I was just going to add, as it was said earlier about having different levels or designing systems for data centers. They're not all created equal. So we have, yes, data centers are a different occupancy group or a different type of environment, but then within that we should have subcategories. And you spoke very well about that, and that's something that should be added into the code as well, mainly to bring awareness to it, that it's not just a one-size-fits-all application.
Yeah, and I think again it's been said on numerous occasions during the discussion today. It's all about what the tolerance is to the risk, and what is it that the operator of the data center is prepared to compromise. If you're not prepared to compromise on anything, then you put all the measures in that we've discussed. It all depends about the resilience. It depends about, Chris has spoke about redundancy within the within that particular facility and beyond that facility. It's all about bringing all the right stakeholders together so that an informed decision can be made and people walk away from the decision knowing exactly what risk that they still retain with the decisions that have been made.
I get to ride on the coattails of a great panel. All I need to say is ditto. I actually don't think there's more to add. You've done a great job, well done.
Thank you for joining us today. If you have questions or want to further explore topics from this panel, we encourage you to reach out to your Johnson Controls Fire Protection representative or visit johnsoncontrols.com.